Hello, my name is Stephen Hawking. As you can see, we are orbiting planet Earth at almost 8 kilometers a second at an altitude of 400 kilometers. This is the velocity and altitude of the International Space Station. Now we are traveling at just over 16 kilometers a second. This is more than double the velocity of the International Space Station. This was the velocity of the New Horizons probe when it was launched in 2006. Although it may seem fast, it is in fact an insignificant velocity compared to others that can be found elsewhere in the universe. We are now stationary relative to the Sun. As you can see, Earth is receding away from us at 30 kilometers a second. At this speed, Earth is able to orbit once around the Sun in 365 and a quarter days. Other planetary bodies in our solar system also orbit the Sun, except at different speeds, depending on how close they are. Now we are just above the surface of the Sun. We are stationary relative to the galactic center, and the Sun is moving away from us at around 230 kilometers a second. This is the velocity that the Sun needs to orbit our galaxy, the Milky Way, but it would still take more than 200 million years to complete one orbit. When the Earth was in this very spot just one orbit ago of the galaxy, it was the Triassic period when there was only a single continent, called Pangaea. At that time, dinosaurs had just evolved and were taking their first steps. As you can see, we are outside of our galaxy, but what you might not know is it is moving at 580 kilometers a second through the universe. This might look like a still image, but in fact the velocity of the galaxy is nothing compared to its size and the size of the cosmos it is flying through. Let's move on to the fastest known velocity in the universe, the speed of light. Traveling at 299,792,458 meters a second, it outruns all the other velocities by far. We are traveling at the speed of light, going past Earth. It only takes about 2 seconds to go from one side of the Moon's orbit to the other, but a split second to go past Earth. We are traveling at the speed of light, going past Saturn. Saturn is much larger than Earth, so we will pass it in more time. Because of the vast distance between Earth and Saturn, it would take just over 70 minutes for light to be seen from Saturn at its closest approach. Next to us is the Sun, and we are traveling past it at light speed. Directly in front of us is Alpha Centauri, the closest star to our Sun. Despite the speed of light being the fastest known velocity in the universe, it would take hours for light to reach objects on the edge of the solar system, such as Pluto, more than 4 years to reach our closest star, and about 2.5 million years to reach our neighboring galaxy, Andromeda or M31. This is Sagittarius A. It is a supermassive black hole at the center of the Milky Way. It's what all stars and other matter orbits that is in our galaxy. As we zoom out of the galactic center, we can see the Milky Way as a whole. Traveling at the speed of light from one side to the other will take you 100,000 years to do so. There are black holes all over the Milky Way. There is an estimate of 100 million black holes in our galaxy. This black hole that can be seen here is a stellar mass black hole, meaning it was once a supermassive star that collapsed under its own gravity. As we enter the black hole, you will notice that everything becomes blue-shifted and the stars and galaxy beyond the event horizon will start to become distorted. This is due to the black hole's immense gravity that is able to bend light. It's only once you're past the event horizon when nothing can escape, not even light.